So volume and surface area of composite shapes. So a composite shape means two shapes put together or a shape within a shape that we can then look at. So we have a cylindrical can that contains 3 tightly packed tennis balls, each with a diameter of 75 millimeters. So we need to find the volume of the can to the nearest cubic millimeter. So if we look at the volume of a cylinder is pi r squared h. So pi times our radius. Now, this is our diameter. So if our diameter is 75 millimeters, our radius is going to be half of that. So we get 37.5 millimeters. So we get our radius as 37.5 squared. Then we also need our height. So our height, if you think our diameter also goes this way, our height is going to be 75 times 3, which gives us 225. And that would then give us, again, quite a large number because we're working with millimeters. So millimeters cubed. What we then have to do is then look at, well, what percentage of the can's volume is taken up by the tennis balls. So we're looking at the volume. So our volume is 4/3 pi r squared, pi r cubed. So 4/3 times pi times our radius of 37.5 cubed, which gives us, again, another larger number. So that's the volume of just one of those tennis balls. But I have 3 of those tennis balls, so I need to multiply that by 3. So our 3 balls gives us so that's the volume of all 3 tennis balls. So we're looking at the percentage of that of the volume of the cylinder. So the percentage is the tennis ball volume over the volume of the entire cylinder. And we times by 100 to make it our percentage. So we end up with 66.66 continuing, or 66.7%. Part C says, if the 3 balls are packed tightly into a square prism instead of a cylinder, what would be the volume of the prism? So for C, we would have volume equals AH. Now, if we think of a square, it has to fit the tennis balls, so it's going to be 75 times 75, area of a square, and then times by the height of the 3 of them, so 225. So we end up with this being the volume of our square, if it was packed into a square. And then it says, why do manufacturers pack tennis balls into cylindrical cans? Justify your answer. So what it means is if we have them in a square, there's more space for air, there's more blank space, so to speak. If it's in a cylinder, it's our most efficient packaging. As it has the least amount of air, or the least amount of free space within that cylinder.